really be capable to support and fight that virus in a different way. Once again, doesn't apply for herpes viruses, and that's why there are, at least to me, that are extremely interesting type of viruses, because they survive in what is called in latency in the body, and they can have the same outbreak several times during a time life without compromising the health directly of the host, because at the end it's not the intention of the virus, if you could say, to kill the host. It's simply to reproduce and to spread. So herpes virus is different than many groups of viruses. Is exactly that they survive in the immune system, or they survive in the body, and they just express and they just become evident when there is a suppression of the immune system. Where exactly they're localized in humans, they have been found in many different places. Where in other animals, I think they will change, but they usually is located in the limb and the numbs. But yeah, so I don't think so there is exactly negative things about viruses. I think it's something that, especially if you look through evolution, it might be something that if we're analyzing and we go deeper, we might find really the really interesting part about understanding our own biology by understanding the biology of viruses.
We are very complicated animals. We have a lot of organs and cell types, and so. And I suppose that if you go to more simple organisms, you would come to a certain point where you actually don't have any virus in that organism. Is that right?
I guess if you go really back in time, I mean, for simple organisms, you will go bacteria or even lower. No, there are viruses completely specialized on attacking bacteria. There are viruses completely specialized in really microorganisms that live in the water. So virus is something that has evolved in such a magnificent way that I think, virtually every single living organism and non-living organism is attacked by the virus. It has found viruses that attack other viruses. So as a matter of fact, yes, I think not. I think viruses has evolved to attack everything, if you could say the attack, or simply to interact with a different type of organism for the simple function of reproducing. The first thing, a virus is not a living organism. It cannot be compared. A bacteria is something that you could already say that is because there is a clear function, there is a clear structure in which the organism is capable to reproduce by himself. Viruses are simply a package of proteins, the ones that have membrane, this package, just proteins containing DNA or RNA information with a simple function to just jump into a system and release the information and reproduce. It's extremely smart. So because of that simplicity is what they have been this cosmopolitan ability to adapt and basically be able to infect any other type of organism. So even if you go the most basic level, I think if you really dig deeper, you will find that simple organism or living thing can be attacked by a virus.
But you still think that some of the very simple organisms actually could be without, at a certain point, a virus. So it would be possible to think of an organism without any virus, a latent virus in it. Or what?
It is possible, of course. Anything is possible, but by a simple organism will be something so simple that doesn't really have the enough mechanism to create a real function, and is once again probably something that bacteriophages that is imitating in a way the function of a bacteria or a virus, and that's why they can be camouflaged and be escaped from a virus. Because by going as a simple, I cannot remotely thinking anything more simple than a virus. So, and if viruses are capable to infect another virus itself, they will be able virtually to infect anything. But of course, it could be that And I cannot think of any example right now, but for sure there are.
I have another question, because if you think about very old organisms, maybe 20,000 years old, or maybe 700,000 years old, you can find the gene of the horse, which is 700,000, which is 0.7 million years old. And can you also find out what virus that horse would have had?
Sorry,
Can you find out the viruses of that horse? That would be the latent viruses.
Yeah, it's very, very unlikely, because the main difference is when we do ancient DNA studies, you rely on finding the host, in that case the organism DNA, in the cells that have been either from bone or hair, they have been preserved for really long periods. Viruses themselves, the way how they keep and protect their DNA is by creating viral capsids. So there is a really very solid structure that they just can survive. But so far, I don't think so. There is no one who's been able to find any virus that has survived for longer periods, for really that longer periods in the body. However,
so studying the disease called Spanish flu. The Spanish flu was influenza type, and I know that it has been a project and has been successfully made that to find out the reason why the Spanish flu virus was so much more deadly than normal flu. That the way to find this Spanish flu virus was to dig in very old, almost permafrost areas in Canada, I think it was, or was it Alaska? But it was something like that. And they found some bodies who had been killed by the Spanish flu, and they were able to find the virus in that body. Yeah. You heard about that?
Yeah. I think it's some of my colleagues from the Center for Geogenetics that are also involved in that project. And there is a really high potential to do it in that way. If that's the case, why northern part of the world, they're really good for ancient DNA studies, because if you have the opportunity to preserve DNA, then if you have the opportunity to preserve DNA from the human, from the host, of course you will have a high potential to find any other pathogen or parasite infecting the host. In the case of, the DNA is something that degrades extremely fast, especially through radiation or light or almost anything. And by degradate, it's simply that the sequence, the DNA that you get in one strand, it starts breaking down. And the more you break it down, the more information you lose and the harder to recover it. If you take a piece of meat and you put it in the freezer, the DNA, it will survive there for as long as you want. The lower the temperature and the more completely isolated from light, that sample will be really potential in 100 years, definitely, for doing any ancient DNA study. So that's a really good, and absolutely it's believable that they were able to cut samples from the Spanish flu from the Spanish flu was something in the beginning of the 19th century, so it's absolutely possible to do that if there was a permafrost conservation.
This was the Spanish flu virus. Is there any other viruses you could think of that would be of interest to dig from the past?
I guess once again, everything there is a high potential. It's more what you're targeting to research, and that's usually what the limitation of most of the DNA studies. That of course you need to focus on one particular type of DNA. And if you do something what's a shotgun sequencing, that basically you are sequencing everything that is in there, once again, is what are you searching for? Because there is it's a really huge variety. And if you already found a human DNA, you have a Spanish flu DNA, there is a high potential you will find more things there. You might have bacterial infection, you might find another herpes viruses, because if those persons die from the Spanish flu, and in the process of getting sick, I believe that when the immune system starts going down, and usually that's how disease works, it's no one unique organism what is killing the host. Is that at the moment that the main disease is affecting, all the pathogens enter the system and start also messing around. So if you really start digging more information, I'm sure you will find bacteria, herpes virus, and who knows what else will be found in those samples. It's more like the searching for the data, and that's the part that the bioinformaticians do. That is very, it's very demanding and takes a lot of time, but it's possible to do it.
Are you planning to go other places and around the globe? You have been in the Middle East and in the Caribbean, other places where you have been or are going?
No, with this time, I have, as I say, I have less than 3 months before I am supposed to finish handling my thesis. So no, for now I am just writing, analyzing, and hibernating in my office. So no more traveling for now.
Okay. Held og lykke.
Tak.
Held og lykke means
Tak.
I hope that it will succeed and you will have a good degree and your research will be finished.
Thank you.
We'll have another research.
Let's see what comes.
Thank you very much for your interview.
Thank you very much to you.